Hi friends, in this video we are going to find the extreme points of the function in multidimensional. The first step, so this is the given function. So first step I will do it as I will find the stationary points. What is the stationary points? Gradient of f equal to 0 vector. I will make it and I will find the corresponding those points. What is the gradient of f? Gradient of f equal to dou f by dou x1, dou f by dou x2 and so on, dou f by dou xn transpose, correct? So it's a column vector, I want to write it. So here n is two variables only in the given problem. So our gradient of f equal to dou f by dou x1, dou f by dou x2. This is the gradient I have to find and equal to the 0 vector. So first of all I want to find what is the dou f by dou x1. So if you take derivative with respect to x1 partially, so 3 times x1 square plus 4 times x1, so no other terms, correct? So this is, second is dou f by dou x2 I have to evaluate. So this is simple, but x2 I want to take derivative with respect to partially for f. So 6 times x2, sorry 3 times x2 square plus 8 times x2. So then meaning then my gradient of f equal to 3 times x1 square plus 4 times x1, 3 times x2 square plus 8 times x2. I want to equal, this guy is equal to 0. That is my, to find the extreme points. So this implies 3 times x1 square plus 4 times x1, 3 times x2 square plus 8 times x2 equal to 0, 0. So that meaning the first component is 0 and the second component is equal to 0. So this implies 3 times x1 square plus 4 times x1 equal to 0 and 3 times x2 square plus 8 times x2 equal to 0. So the first equation implies x1 you can take commonly, so 3 times x1 plus 4 equal to 0. The second equation implies x2 you take commonly, so 3 times x2 plus 8 equal to 0. This implies, so from this implies x1 equal to 0 or x1 equal to minus 4 divided by 3. Similarly, the second equation implies x2 equal to 0 or x2 equal to minus 8 divided by 3. So now I want to find the x1, the multidimensional. So the stationary points are so first two components you want to write it as x1 comma x2. So The first component is x1 0, comma 0. Second is x1 is still 0, x2 is minus 8 divided by 3. Third station point, I will fix the first component is minus 4 by 3. Second component is 0 and fourth component is minus 4 divided by 3, comma minus 8 divided by 3. These are the stationary points. Now I want to, this is the necessary conditions also, okay. So this condition we called as a necessary conditions for the extreme points, okay. So these extreme points, we cannot say extreme point, this what are the points are satisfies, those points we called as a stationary points also. Okay. So we find these are my stationary points. Next is I want to check the sufficient condition. What is the sufficient condition? You will make it as a Hessian matrix. So now what is the Hessian matrix? H we called as a Hessian matrix. This matrix is dou square f by dou x1 square, dou square f by dou x1 x2, dou square f by dou x1 dou x3 and so on, dou square f by dou x1 dou xn, dou square f by dou x2 x1, dou square f by dou x2 square, dou square f by dou x2 dou x3, dou x2 dou xn, finally dou square f by dou xn dou x1, dou square f by dou xn dou x2, dou square f by dou xn dou x3, so this is our Hessian matrix. So what is the sufficient condition says, whenever the H is clearly symmetric, because these two are always equal provided f is continuous from Claira's theorem. H is symmetric and H is positive definite. H is positive definite, then relative minimum. So H is symmetric is compulsory and H is positive definite means then relatively minimum. H is symmetric and H is negative definite, then relative maximum. Okay. Suppose H is symmetric and H is semi-definite, then this test is inconclusive, test fails. Okay, test we cannot say anything, and H is indefinite, then those points saddle points. Okay. So what is H is positive definite means H is symmetric, all the eigenvalues are H is positive definite means all eigenvalues are positive. All eigenvalues are positive, we say that positive definite. Negative definite means all the eigenvalues are negative, then it is negative definite. The semi-definite means one of the eigenvalues are 0, one of the eigenvalue is 0, remaining all are positive or negative. Positive, all are positive, or all are negative. What is H is definite means? So H is indefinite means they have the different signs. That is, some of the eigenvalues are positive, some of the eigenvalues are negative. That is, we call as H is indefinite. So here only two variables only there. So our Hessian matrix become 2 by 2 matrix. So our H equal to dou square F by dou x1 square, dou square F by dou x1 x2, dou square F by dou x2 dou x1, dou square F by dou x2 square. This is my Hessian matrix. So I want to find dou square F by dou x1 square. So I already calculate what is the dou F by dou x1. So 3 times x1 square plus 4 times x1. So we got it as 6 times x1 plus 4. Dou square F by dou x1 dou x2, it is 0. Similarly, dou square F by dou x2 and dou x1 also 0. Dou square F by dou x2 square, we will get it as 6 times x2 plus 8. So now my Hessian matrix becomes a diagonal matrix. So 6 times x1 plus 4, 0, 0, 6 times x2 plus 8. So now I want to check all the state points only I am going to check, correct? So 0, 0 and 0, minus 8 by 3 and those points only I will check. At 0, 0, my Hessian matrix become, you put the x1 value is 0, x2 value is 0 in this matrix. So we will get it as 6 times 0 plus 4 is 4, 0, 0, 8. So this is the diagonal matrix. So all the eigenvalues are main diagonal elements only. So eigenvalues are 4 and 8. So the given matrix is H is positive, definite. So this implies the 0, 0 point is relative minimum. So second stationary point is 0, minus 8 divided by 3. So now our H is so here x1 is 0, so 4 only will come. So here 0, here 0. So 6 times x by 6 times minus 8 divided by 3 plus 8. So our Hessian matrix is 4, 0, 0. This is become 2 minus 16. Minus 16 plus 8 is minus 8. Okay. So this is also again diagonal matrix only. So one of the eigenvalues are 4 and minus 8. So that meaning is the given Hessian matrix are indefinite because one eigenvalue is positive, one eigenvalue is negative. So H is indefinite. So this is saddle points. So 0, minus 8 by 3 is saddle points. So now next point is at another stationary point is minus 4 divided by 3, 0. So our Hessian matrix is so 6 times x1 plus 4. So 6 times x1 divided by 4. So 4 divided by 3 plus 4, 0, 0. So 6 times x2 plus 8. x2 is 0. So simply will come here is 8 only. So our Hessian matrix is this guy become 2. So our matrix is minus 8. So we'll get it as minus 8 plus 4 is minus 4, 0, 0 and 8. Here eigenvalues are main diagonal elements only, correct? Eigenvalues are So main diagonal elements only, minus 4 and 8. So H is again indefinite. So thus minus 4 divided by 3 comma 0 is saddle point. Next is the last point is minus 4 divided by 3 comma minus 8 divided by 3. Then our Hessian matrix is, we already calculated, minus 4 by 3 means we will get minus 4, 0, 0 and minus 8. We already calculated. So this is the eigenvalues are minus 4 and minus 8. So all the eigenvalues are negative. So thus H is negative definite. This implies the minus 4 by 3 minus 8 divided by 3 is, the point is relative maximum. I hope you understand what is the necessary condition for the find the stationary points and how to find the sufficient conditions using the Hessian matrix, and find the eigenvalues using to satisfy the it's a relative maximum or relative minimum or saddle points or test fields, those keys. Thank you for watching this video.